This is 5.2, writing expressions. So we're going to be writing out the algebraic expressions that we were using in 5.1. So some keywords and phrases for when we go to write them. If we see the word, or if we're going to write addition, we could see words like added to, plus, sum of, more than, increased by, a total of, and the word and. So if you say 5 and 3, that means 5 plus 3. For subtraction, we could see words like subtracted from, minus, difference of, less than, decreased by, fewer than, and take away. Multiplication has, we could say multiplied by, times, product of, and twice. We would say twice for 2 times. We could say triple for 3 times. Those are probably the only kinds of words that you will be seeing for a specific number in that way. For division, we could say divided by, the quotient of, things like that. So, a few examples. We are going to write each phrase as an expression. So we're taking the phrase and putting it into the numbers for it. So if we say 6 fewer than 20, I can look back at the list and say, okay, I have 6 and 20, but what does fewer than mean? Where can I find it up here? And I see that it is here for subtraction. So this is 6 fewer than 20, which means I take 20 and subtract 6. So that's 20 minus 6. For the product of 15 and 4, product I know means multiply. So I'm going to multiply 15 times 4. I have 10 more than the number x. More than means adding, so I have 10 plus x. We could write it x plus 10. Addition and multiplication are the same forwards and backwards, so the order does not matter. The order does matter for subtraction and division. And here if we have a number minus 25, I don't know what a number is, so I'm going to choose x as default. A number minus 25 is x minus 25. And one more. The quotient of a number and 7. So I'm going to do a number x divided by 7. I could write it as a fraction because fractions mean to divide, or I can use the division symbol here. Make sure that the number that's listed first, a quotient of a number, is the one that is on top, the one that's being divided. And the 7 is the one that we are dividing by. So here, this problem says the length of a room is 5 feet less than the width. Write the equation. So I have the length is 5 feet less, so I'm taking away 5 feet from the than the width. So less than, I know that I'm subtracting, and the length is 5 less than. So the width is on the other side of the equal sign. And I have the depth of a pool is 3 feet more than twice the width. So I have the depth of a pool is, so the depth would be equal to twice the width, so I'm 2 times the width, but 3 more than that, so I'm adding 3. So twice the width plus 3. Alright, you plant a tree that is 15 inches tall. It grows 10 inches per year. Write an expression that represents the height in inches after t number of years. And then what is the height after 8 years? So if it grows 10 inches per year, and t means the number of years, that is how we find the rate. But it started at 15. So whatever after 1 year, we'd have 10 times 1 plus its original height of 15. So if it's 8 years, that means t is now 8. So I plug in 8 for t, and then I find the answer. So 10 times 8 is 80. Don't forget your order of operations. And then add 15. So after 8 years, the tree is 95 inches tall. That's over 7 feet, probably over 8 feet. So if we convert to feet, I know that I have 12 inches in 1 foot. So if I make my chart, feet to inches, that is 1 foot for 12 inches, but I have 95 inches, so that goes here in the bottom. And to get from 95 to 12, I could divide by 7.9. So then multiplying and dividing undo each other. To go from 12 to 95, I'd multiply by 7.9. So 1 gets multiplied by 7.9, and the answer is 7.9 feet, or 7 feet 8 inches. To get the inches, I'd have to figure out how many inches are left over after I get the 7 feet. So I was wrong in saying that it is almost 8 feet tall, but it was a good estimate.